Voice of Industry.
Voice of Industries.
Eric, welcome to Voice of Industries. I'm very happy to have you today to discuss about how Application use data internally to support its product design. I should mention that this podcast is part of a series of 3 about application digital transformation. First of all, could you tell us a bit about yourself and what you do at Application?
Thank you first for the kind invitation. It's a real pleasure to participate to your podcast. In fact, I started with a chemical engineering background from the chemistry school of Paris, and I made a PhD in the field of simulation first. And since 20 years now, I'm involved in developing solutions of purifications with chromatography, with ion exchange and membranes. And now I am responsible of the technology for application, which includes the R&D, the innovation, and our process engineer team.
Okay, great. So if I understand well, Application is developing solutions in the purification field, including ion exchange, chromatography, and membrane separation.
Yes, we develop the 3 technologies for our customers. We can include additional technologies like evaporation, but this is not our core activity. So we can integrate additional technologies. We deeply investigate the understanding of our core technologies.
Could you explain to us in more details what product design means at Application and what are the related challenges?
We recently have developed 3 services, and to develop these 2 products, one is Run, the other is called Perform, we followed a main guidance that was to bring expertise, make our expertise available for our customers. So we had 2 challenges to overcome. The first challenge was to be able to put our expertise into algorithms. And these algorithms can be mechanistic algorithms or linked to statistics algorithms that are more related with data. That was the first challenge, which is to understand ourselves in a deep understanding of a know-how which is more related to something which is tacit, and we had to make it explicit, which was a key step for us. The other part was to make it really available for the customer at the right time and the right place, which means that the user needs to be aware, informed by our tools in a matter of 30 seconds or 1 minute, and in these 30 seconds and 1 minute, all our expertise needs to come with a series of information that are focused on the need of customer. So to develop that, we have failed a lot. We iterated a lot. And so it was like having the main guidance and keep it, but the way was not a straight line.
To what I understood, you also have internally some pilot facilities.
Yes.
And I can imagine that this kind of facility generates a lot of data also to improve the design of your systems.
We have, it's through some different levels of understanding for our systems. The first level is the lab level, where we can collect the main behaviors of the product that we need to purify and how we can deal with it at the pilot scale, industrial scale. The very first stage being the lab. The second stage is not the pilot. The second stage is the in silico simulation, which is also key for us as an understanding. Then we go to the pilot, and then we go to industrial scale. The main information we have them right now. We have this set of information at the pilot scale. Regarding the industrial scale, we offer services but also confidentiality. So we don't have a deep look at all the data of our customers, only key data, so we know that our services are working well.
And how did you digitalize all these different activities?
With a lot of work.
And many years.
And many years. The simulation tools is a result of decades of developments And this is not creating a lot of data. We need only few data to do models. And more recently, we started to develop some data-oriented models. Then we had to recruit some new profiles within the company, data scientists. And now we need to deal with a lot of data. And that's why when we identify that we had on one hand our algorithms and on the other hand the need to deal with a lot of data, that we were looking for a partner, and we found Optimistic. And what I found myself really enthusiastic regarding the Optimistic solution is the fact that it's an open solution with the capability that we have now to put all our algorithm within your solution.
Okay. Thanks for saying that. One question I have, and I think the people listening to us may have this question, is because there is new kind of approach regarding algorithm. I would say there is a simulation, as you mentioned, using physics and chemical theories. There is now a lot of things around AI and machine learning, and I have the feeling that for industrials there is a kind of way in between, combining both quality of these two aspects with surrogate models that use simulation data to build machine learning models. And what is your opinion on that? And
in fact, I'm using some kind of personal approach, which is to say, anytime we have an idea of the mechanism which is behind something we observe, we have to put it on a mechanical simulation. Anytime there is something that our eye, an expert eye, can understand without being able to transcript it with equations, then it's a place for AI.
So when there is, I would say, data related to observations and real-life observations, then you use machine learning.
Shape recognition.
Yes, and on the other hand, when you have all the theoretical background, then you use theoretical simulation or theoretical modeling.
All or part of.
And you combine both of them.
And we combine both of them anytime we can.
Yeah, I think it's an important thing because in the past 10 years, there was a lot of hype around machine learning. And sometimes people forget this, I would say, theoretical approach. And really what we can see today is the combining both, the best of both worlds is really a way to really solve the industrial problems.
It's never black or white, it's always in between.
What was the benefits for your teams of all this digitization?
First, understanding the fact that we started many years ago by reacting when we were to optimize something. We were observing that there is a deviation, so we try to correct it, which is good, of course. But now when we do a correction, we know by how much we have to change one parameter and by how much we expect something to change. So we change the value of 0.01 and then we expect 5% better yield. And when we do not have 5% better yield, then it leads us to additional questions. So we have a better understanding of that. Because it works most of the time, it means that we can pilot more quickly right now. And for our customers, when they have on their dashboard an indicator which is not optimal, they have now the access to recommendations that tell them what they can improve on their machine. And the matter is that they have their information within a frame of a minute or 2 minutes. So
and not weeks or months.
Not weeks, so they can really act fast, and that's the same. We developed these tools relying on our own R&D because they are our best beta tester.
Okay, so that's why you implemented first this kind of tools on your pilots. So.
Yes, in fact we have the strongest feedbacks without any filters. Comes from within our company.
And having done this journey toward digitization, did it change the way you understand your equipment and system behave at your customer sites? And did you find some surprising information or surprising behavior?
I found that our customers are good in using the systems first. However, we are now more keen to look at the way they understand, at the way they behave, and the problems that they are facing on a daily manner. So these tools that we developed create a lot of empathy with our customer. And the fact that I think our job is to make sure they can use their system without knowing how the system works.
So that means your target is to have systems where you don't need a lot of expertise to get the best value from them.
Yes, the point is that an expert can find a lot of information having a deeper use of our solutions or our systems, but also a user, an operator, which is operating, for example, by night in difficult conditions, can have fruitful informations and reliable informations just using a system without really understanding what created this, for example, recommendations that can come.
Yes, if I remember well, 20 years ago, we are talking a lot about experts system. Mm-hmm. In a way, it's a kind of similar approach, but
yes.
using newer technology to provide with your full process system all the, I would say, embedded expertise yes. that can support both the operators and process experts at the customer sites.
Exactly.
How do you expect digitalization will affect your product design in the future? What is the, I would say, your vision for the coming years?
That will open a lot of doors, and we are now able to create a relation with our customer, which is, I will call it more intense. First, we went, we had to deliver the system, then we had to make it work for the first month, and then the door is closed and we don't see anything until we come for visits. So now we have the chance to have our digital solutions on technologies that we know, our systems or other systems, and be with the customer, and if he needs, tell him how he can improve its performances, how he can use less energy, how he can produce a better quality, which at the end is also good for the carbon footprint. Mm-hmm. And we have also developed these tools to be able to quantify the carbon footprint. And one of the key points should be that these tools are able in the future to decrease the carbon footprints of our customer.
So does that mean that in the end it changes also the kind of profile you have internally at Application to develop all this system?
We already changed. We have two profiles that we never have hired before that are related to data science and digital product development, because it's a new way to consider data on one hand, and also we need to be able to collaborate with supplier that will develop for us websites, that will develop for us apps. And so that's we evolved, and we were a company made of engineers and technicians, and now we have new profiles coming, and which is good.
Great. Finally, what can you recommend to companies willing to use data to improve their product design?
Be patient. Make sure that you are using the right mindset, which is the data is not only the key, but a good data is necessary for having good models, and some work has to be done in understanding the structure of the data and the reliability of the data. Additionally, it may need to have new profiles, new experiences regarding what we will observe. So be prepared to iterate, be prepared to have some visions, problems, but at the end, success.
Okay, thank you, Eric, for sharing your experience.
My pleasure.
Thank you.